Hello, this is Brett from SurvivalComms, and today we're going to talk about the magic carpet, the conductive blanket, Faraday cloth, or whatever you happen to call it, and its use as a ground plane for vertical antennas and things of that nature. It certainly made the deployment of the antenna system fast. I mean, we had a working 20-meter vertical antenna that was ground mounted up in like 2 minutes, soup to nuts. But the question we have to ask ourselves is this a suitable replacement for a field of resonant radials? And we're going to gather that data today. Now, first of all, I'm going to talk about the material itself. It's conductive, and there's been a lot of other creators that have talked about it. Now, what I did when I made my attachment is I wanted to see just how easily it sews, and you can see that I've hemmed it. At the center where the spike goes through, I've taken and placed a grommet, and I've backed the grommet and the material up with some rubber material here. You can see it on the working side here. So whenever the spike goes through into the ground, it goes right through this grommet. My attachment I made to the fabric to tie it into the spike is just with this 18 gauge silicone wire, and I use a Chicago screw, and I've also backed it up with rubber on both sides to make this a very strong mechanical connection, and the connector itself is right up against the fabric, so it's also a nice positive electrical connection as well. I also took the liberty of placing grommets that are reinforced in the same fashion in all four corners. Let's briefly discuss the gear we're going to be using in our test today. First is our feed line. We have 50 foot of RG8X on one of my Christmas lights winders. We have a chameleon spike, and that's mounted to a piece of aluminum that I cut out and then put a mobile mount on it, and that's our mount for our antenna system. These are my two radial bundles here, and there is 6 elements in total. And there's 140, 120, 130, 117, 115, and 110 meter element. And all this together. This is our magic carpet, conductive blanket, whatever have you. Inside I have a stuff sack I sewed up for it. Here's our coil for our antenna, the MP-1 super antenna. You can see it's got a telescoping whip on top. And these two rods here thread together and go into our base here and go between the coil and the base. This is our frequency guide, and this is how you set the super antenna here as shown. Now, today's test, we're going to be testing on the 20 meter band, and we're going to be testing using the magic carpet versus using my radial kit, and let's see what our results are. Let's get started. These are our SWR sweeps of the 20 meter band, and first up is our Faraday cloth only configuration. The useful bandwidth of this configuration easily covers the 20 meter band, and the lowest value in this sweep is a tad under 1/4:1. Next up, we have our radial array attached only. Now, I realize a common consensus is that 1/10 of a wavelength radials are considered sufficient for ground-mounted vertical antennas. However, I contend that the more wire you put on the ground using a ground-mounted vertical antenna, the better off you are, and the SWR sweeps aren't all that important. A 1/8:1, that's fine with me. I'll run that all day long. We're going to start our testing, and we're using raw radio, no tuner involved. Let's get started. Next are our field strength measurements taken during the whisper testing, and these represent 4 watts of peak envelope power measured during transmit sequences 40 feet away. This is our Faraday cloth only variant, and the maximum meter deflection observed was 6. Next is our radial only variant, and the maximum meter deflection observed was a tad over 7. Not a tremendous difference, however, due to the overall diminutive deflection of the meter in this test, a difference of 1 graduation is greater than a 10% increase. Here is our whisper test of the Faraday cloth equipped ground mounted vertical on 20 meters at 1830 UTC and the data captured. I'm running Whisper for 20-minute sequences, capturing data for 1/2 of an hour, and then taking 15 minutes to reconfigure the antenna, then testing the next configuration for 20 minutes, ensuring there is no overlap in data captured. Now here is our Whisper test of the radial equipped ground mounted vertical on 20 meters at 1905 UTC and the data captured. It is obvious that the radial equipped antenna outperformed the Faraday cloth equipped antenna considerably, not only in contact volume, but with a much more balanced total of stations received to stations receiving my station. This was in spite of the match being less than ideal in this configuration if one was to look at SWR sweep data alone as a performance indicator. Now, it is true that improved propagation between testing sequences could be responsible, so I repeated this testing over 4 days, and in this time, the Faraday cloth equipped variant always fell behind performance-wise to the radial equipped variant. So, like so many things, it is a question of convenience over effort, and in timing myself, the difference in deploying my radial kit added an average of 2 minutes 15 seconds to antenna setup time, with a consistent soup to nuts setup time of under 5 minutes. This was a fun experiment, and use this data as you will. I hope this helps. This is Brett from SurvivalComms. Until next time.